Hello everybody and welcome to my channel. Today, as a second part of the SpeedyBee Mario 5 series, I'm gonna flash and configure Inav on this drone. The stack is the SpeedyBee F405V4 and as a default it comes with the Betaflight firmware installed in. But it can also run Inav 2 as stated by the manufacturer. Before flashing the Inav firmware, we connect the drone to Betaflight and take notes of, for instance, the port tab and all the other useful information we might need to transfer into Inav then. And we also need to make a backup of the Betaflight configuration. Okay, let's jump on Betaflight and we start to get the drone ready. Okay, here we are in the ports tab. I had previously set everything in here to check if the drone was working. So first one, we got the USB, so configuration MCP port is enabled. UART1 is for the O3A unit. UART2 is for the receiver. UART3 is an empty UART port. UART4, the MSP is enabled, that's for the Wi-Fi. The UART5 is set for the ESC telemetry and the UART6 for the GPS. And that's all the information we need to take note of. And then we jump into the power and battery and we need to take a note of the amperage meter of the scale, which is 400 and offset is 0. This helps the reading of the milliampere of your battery. Then we go into the preset tab, and even if I didn't do anything except for the ports tab, we just save a backup anyway. So click on save backup and choose the location where you want. So after saving the backup from the presets tab, we go into the CLI and we type dump and give us all the information of the configuration of the drone, and again we save this one as well. Save to file and again choose your destination folder and save in it. Okay, now we write version, so give us the information of the flight controller, and this one is at 4.4.3, so we can make a note of the firmware version in case we want to come back to Betaflight. And the name of the board or the target name is SpeedyBee F405V4, and that's the name we need to keep in mind when we then choose the Inav target firmware, this one. So here we are done, and we can now jump into Inav configurator. Okay, here we are on Inav configurator. So we are gonna flash the latest Inav firmware on our drone. What we need to do first is to press and hold the boot button on our flight controller while we plug the USB cable in, so we get the flight controller to be in DFU mode. Here we are. Now we click on firmware flasher. Need to select the target and we write SpeedyBee here and give us all the SpeedyBee boards. And our one is the SpeedyBee F405V4. You're gonna choose the latest, which is at the moment of the video the 7.1.2. Click on full chip erase and load firmware online. Okay, firmware has been loaded and we can now flash. Okay, the firmware has been successfully installed on our flight controller. We can now connect, and here it asks us what type of drone we have. So ours is a 5-inch drone, so mini quad with 5-inch propellers, and we choose this one. Okay, here we are in the Inav configurator, and now we are ready to configure the drone. We start from the setup tab, and here we can just click on reset Z axis, and as we can see, the drone slightly spin on the left, and that's because the compass has been detected and is not properly set yet. Anyway, we're gonna do this one later. Jump onto the calibration tab. We're gonna calibrate the accelerometer now, and later on you're gonna calibrate the compass. We don't do this now because the compass alignment needs to be adjusted first, since it's sitting backwards. Okay, let's calibrate the accelerometer. Click on here. Place flight control in a position showed in the image, then press calibrate button again. Repeat for each of the 6 positions. Keep it stable during calibration. Okay, so it's up. Okay, calibration is finished. Click OK. Save and reboot. Here we are in the Outputs tab, and this tab is related to the motors of our drone. And first thing, you're gonna enable the motors, and as a ESC protocol, we're gonna choose the D-Shot 300, and we'll leave the other settings here as they are. Go down in the motors idle power. I think we should play around with this value. Fly test the drone, because this number here determines how fast the motors spin in low throttle, which means if you have a lower value than 15 when you perform a trick such as the power loop, you are gonna have more hanging time. However, on the other hand, with the same value, if you fly the drone just like cruising the drone around, and you are in low throttle, there is a good probability that the drone is gonna shake or wobble. So you need to play around with this value and see which one suits your needs the best. I'm gonna leave at 15 now, then gonna fly test the drone and see how it performs. If I'm happy, I'll leave at 15. If something I think needs to be changed, I'm gonna then change the value depending on what needs to be done. And down here we have our motors output. If you want to check how if the motor spins to the right direction, plug the battery in, enable this one, understand the risk, and play one motor at a time and check if they spin to the right direction. Obviously make sure the props are off. And that's it for this tab. You're gonna click on Save and Reboot and go ahead with the other operation. Now in the ports tab, we need to readjust the settings we took note in Betaflight. So this one, the MSP port is enabled, same as in Betaflight. UART1, the MSP port was enabled with the which one was the VTX MSP display port. MSP DisplayPort, but I know that in Inav you need to disable this MSP here. Then UART2 is for the receiver, right? Yep. UART3 was an empty one. UART4, this one, the MSP was enabled for the Wi-Fi connectivity. UART5 was for the ESC telemetry, and UART6 for the GPS. Yep, save and reboot. Okay, everything is here. This one enabled, UART1 DisplayPort, UART2 for the receiver, 3 free, 4 MSP enabled, 5 for the ESC telemetry, and 6 GPS. Okay, now we go into the configuration tab. In the configuration tab, we can see accelerometer, magnetometer have been detected, and the barometer as well. We leave this frequency as it is. Please switch to it. 10 degree connect to the hardware loss. Okay, just leave it as it is. Then we are gonna enable the GPS for navigation and telemetry, and multicolor RGB LT strips. OSD on, air mode always on. Yep, 7 reboot. Have no battery plugged in at the moment. Anyway, this one, I know I'm gonna fly with 1850 mAh battery 6S, and the VTX here we don't need, as we have the DJI-03 unit. This one is more for the analog VTX, I guess. Yep, 7 reboot. We are now in the Failsafe tab, and in here you're gonna just choose the return to home, and I think that's it. 7 reboot. Now we are gonna skip easy tune, PID tuning, and advanced tuning and programming, and we will go straight to the receiver tab. And what I'm gonna do now is turn on my radio.
Welcome to HTX. Designed manual mode.
So the radio is already bound with the receiver, and receiver type serial, and in our case we need to choose crossfire. Okay, 7 reboot. Okay, so throttle, yaw, pitch, and roll. And the RSS channel is channel 12 in our case, so we need to select channel 12. Seven reboot again. Okay, there is already some deadband applied. Should be able to keep the drone steady. We're going to the mode tab, and we're gonna set our mode. Okay, add range, and we click on auto.
Add.
Channel 5 is for arming the drone. Then angle mode, put on auto.
Angle mode.
that's the one. Horizon I'm not gonna use. Then cruise mode.
Position hold. Flight mode cruise.
Okay, that's the one. Position hold. Should be channel 8.
Position hold.
Yep. And now return to home.
Return to home. Angle mode. Return to home.
Yep. Navigation waypoint.
Waypoint. Waypoint.
Yep. Then turtle mode.
Turtle mode on.
And buzzer.
Buzzer active. Buzzer active.
Here we go. And that's it. Click on save. We are in the GPS tab here, and the GPS has been already enabled in the configuration tab. The protocol, we need to use the U-blocks for this specific GPS module, and as a ground assistance I'm gonna choose the South Pan, and everything else I'll leave off. Here we are. And save and reboot. Now we are in the alignment tool, and as we can see here in the simulator, both flight controller and GPS module are pointing forward. However, on our drone, yes, the flight controller points forward, however, the GPS module points backwards. So we need to adjust the yaw axis of the GPS module to 90 degrees, as it is in real life. And 7 reboot. Okay, now that's how it is. I think that's it. Okay, we're done in the alignment tool. We now go back into the calibration tab to calibrate the magnetometer. We are back in the calibration tab, and to calibrate the compass, once we click calibrate the compass, then we have 30 seconds to perform a rotation on each axis, like front, back, left and right. I'm gonna do this via the SpeedyBee app, so I don't have to deal with the USB cable while I rotate the drone. So I'll be back once I'm done. Okay, the calibration has been done. As you can see, these 3 fields here have been filled up with some information. Now if we go to the setup tab, we can see the drone does not spin left anymore. And what I'm gonna do next, I'm probably gonna recalibrate the accelerometer and see how it goes then. Because I'm adding 53 degrees, but I checked on the compass on my phone, it should be at around 150. So let's see. I have understood now why the heading of the drone was not in accordance with the heading of the compass on my phone, and it was not related to the accelerometer calibration, but rather about the position of the GPS and compass module on the drone here in the alignment tool. I previously had this one set on 90 degrees, But honestly, off camera I try to figure out, because as I said, this is my first time dealing with Inav configurator, and I found out that at 0 degree the GPS module then works properly and showing the right heading here, matching the one on my phone, and I'll show you now in the video. And after I've changed the value in the ER slider here, then make sure to recalibrate the compass here, and probably even to recalibrate the accelerometer. I've done those 3 steps, and now the drone is facing pretty much the right degree in heading according to my phone, which is now on my phone it says 142 degrees and here is 137, so which is pretty accurate. Okay, let's jump to the next step. Okay, we are in the OSD tab now, and before we drag and we drop our elements, we need to choose the video format. For the O3A unit, I believe it's the Betaflight HD Combat, and we can enable the shop review guides. Yeah, this shows us where the safe area is to show elements. We can put the payload's name, craft name. I'm gonna put SpeedyBee Mario 5. As units we use metric. Okay. Click on save. And now I'm gonna adjust my elements, so we see once I'm done here. Okay, I've just finished with the OSD elements, and this is my layout. And later on I'm gonna connect to the goggles and see if something needs to be adjusted or if it's fine as it is now. And we are done here. Click save, and we now jump into the LED strips tab. Okay, that's the last step, the LED strip, and we're gonna set some color, something for our LEDs. So first of all, we need to click on wire ordering mode, and we got 4 LEDs on each side. So 1, 2, 3, and 4, 5, 6, 7, and 8. We're gonna select them all, and we can assign a function. I'm gonna go with color, and I'm gonna do the scanner and enable the strobe light effect. I don't know, let's try, and probably it's gonna go through each different color. And let's try this one. Very curious to see how it works. Click on save, and now we're gonna test it. That's the end of this tutorial regarding the SpeedyBee Mario 5 Inav configuration. In the next one I'm gonna fly test, and we will see how the drone performs in position hold, cruise mode and return to home. So please consider subscribing so that you will not miss it. Thank you once again for watching, and we will see you soon. Bye bye.